we've got some key features of a homomorphism. I'm not going to read these out to you because I trust that you can all read them. I do want to point out, though, that you need to be familiar with the proofs of 1 and 2, and you can find those proofs in your book. All right, so let's look at this example. We've got our group A, 0, 1, 2, 3, 4, 5. So, of course, we could also think of that group as our Z6. Under addition mod 6, group B is just negative 1 and 1 under multiplication. So we've got our two groups with their set of values and their operations. And now we've got two functions. We're showing that F is a homomorphism and G is not. Okay, so first I want to point out G is not. Remember, if we're trying to show something is not true, all we need is a single counterexample. Let's look at F first, though. We're wanting to show that it's a homomorphism. So if we're going to show that it's a homomorphism, then we need to show that F of A star B is equal to F of A blob F of B. All right, well, A star B, we're going to take any of our two elements in A and perform our star operation, which is addition mod 6. And then we want to show that using this function, we're going to end up with the same result as if we use this operation and this function together. All right. So let's start with F of A star B. So F of A star B is going to equal F of A plus B mod 6. So remember, we're adding A plus B and then doing the mod 6 on it. And then whatever that result is, we're putting it into F. So putting that into F means we're going to have negative 1 raised to the A plus B mod 6. Well, I know that negative 1 raised to a power is either going to be negative 1 or positive 1, depending on whether this is even or odd. The mod 6, if A plus B is even, the mod 6 is still going to result in an even. If A plus B is odd, the mod 6 on it is going to result in an odd. So I can say that this is just the same as negative 1 to the A plus B power. So the mod 6 isn't changing the result of the negative 1 being raised to the power. Now let's look at F of A blob F of B, and of course here our blob is multiplication. So F of A, I'm going to take one of my values and put it in, and then I'm going to take out another one of my values, and I've got my product multiplied. So what we're going to end up with is negative 1 to the A power. Now I'm doing my blob, which is multiplication, negative 1 to the B power. So it's going to be some combination of negative 1 and 1, and I don't know which one. This is going to end up, though, using our multiplication properties, negative 1 to the A plus B. So F of A star B is the same as F of A and blob F of B. I could be using the multiplication symbol here as well because that's how I've got it defined up here. It'd probably be better if I was using that, actually. I'm going to come in and change it. So it is a homomorphism because this is true and our structure is maintained. The other way we could have shown that is with the Cayley tables. And if you look at the printed version of the notes, you can see that I've made the Cayley tables. So F of X star Y is, of course, our grouping of negative 1s and positive 1s. F of X times F of Y is our grouping of negative 1s and positive 1s. And notice that those Cayley tables are exactly the same. So with the structures being exactly the same, we know that we have a homomorphism. All right, let's look at why G is not a homomorphism. So again, I could use my Cayley tables to help me figure this out, and I just need a single counterexample. So if I've got my two values of g are going to be 1 and -1. So that's similar to what we saw with f of x, but now somehow something's going to be different. So let's think about our values of, let's say, 2. Yeah? And I'm randomly picking one because I have worked it out already. You could start at 0. Remember, with not, you just need a single counterexample. So let's go up here. G of 2 star 2. Well, that's going to be G of 2 plus 2 mod 6, which is going to be 4. And G of 4 is going to equal -1. Now let's do G of 2 times G of 2. Well, G of 2 is 1 times 1 is +1. So we've shown that G of A star B is not equal to G of A times G of B. There's lots of other counterexamples for this. We only need one. So G is not a homomorphism.